Good morning to one and all. Myself, Govardhan DS from Triple second year. My topic in network analysis is concept of bandwidth and Q factor. What is bandwidth? We have to know about the bandwidth. Bandwidth is measured as the amount of data that can be transferred from one point to another within a network in a specific amount of time. Typically, bandwidth is expressed as bit rate and measured in bits per seconds, bps denoted by. First of all, history of bandwidth. Transformed from naked technology serving mainly to interconnect collaborators engaged in government research to a key part of everyday life. In 1995, 0.68% of the world's population reported has access to the internet. Fast forward to 2019, and over half of the globe was connected. And next, why bandwidth is important? Bandwidth is used to transfer data fast, so you can easily access your page to view it. The more bandwidth you have, the more faster you can download more things. Commonly available bandwidth. Your internet service provider is a company that has very high speed connection to the internet but very expensive. Your ISP makes its money by renting some of that high speed connection. Next, bandwidth versus speed. The term bandwidth and speed are often used interchangeable but not correctly. The cause of the confusion may be due in part in part to advertisements by internet service providers ISPs that conflate the two by referring to greater speeds when they truly mean bandwidth. Essentially, speed refers to the rate at which data can be transmitted, while the definition of bandwidth is the capacity of the space. To use the water metaphor again, speed refers to how quickly the water can be pushed through a pipe. Next, how to measure bandwidth. While bandwidth is traditionally expressed in bits per second (bps), modern network links now have far greater capacity, which is why bandwidth is now more often expressed as Mbps or Gbps. Bandwidth connection can be symmetrical, which means that data capacity in the same is in both direction upload and download, or asymmetrical, which means download and upload capacity are not equal. In asymmetrical connections, upload capacity is typically smaller than download capacity. Next, bandwidth signal. It is the block diagram of bandwidth signal. The bandwidth of a signal is defined as the difference between the upper and lower frequencies of a signal generated as seen from the above representation. Bandwidth B of the signal is equal to the difference between the higher or upper frequency and the lower frequency FL. It is measured in terms of hertz, that is the unit of frequency. And next, here we can see the Q factor definition. Quality factor or Q factor is a dimensionless parameter that describes how undamped an oscillator or resonator is. It is the it is defined as the ratio of the peak energy stored in the resonator in a cycle of oscillation to the energy lost per radian of the cycle. It describes the damping in the circuit. It also provides an indication of resonator bandwidth related to its center frequency. Value for quality factor are often seen quoted and be used in defining the performance of an inductor, capacitor, or Turner circuit. Next, Q factor. Higher Q indicates a lower rate of energy loss and the oscillates die out more slowly. A pendulum suspended from a high quality bearing oscillating in air has high Q, while a pendulum immersed in oil has a low one. Resonator with a high quality factor have low dampings so that they ring or vibrate longer. Next, Q factor. Numerical representation. Mathematically, Q factor is the ratio of the energy stored in the oscillating resonator to the energy dissipated per cycle by damping process. Q is equals to 2 pi energy stored by energy dissipated per cycle. 2 pi Fr is by into energy stored by power loss. Fr is equals to resonating frequency. Q is equals to 1 by 2 pi, and damping ratio is equals to 1 by 2q. And next, Q factor interpretation. As system with lower quality factor, Q is less than 1 by 2 is said to be overdamped. A system with a high quality factor, Q is greater than 1 by 2 is said to be underdamped. A system with an intermediate quality factor Q equals to 1 by 2 is said to be critically damped. And next, Q factor effects. Bandwidth BW. With Q factor increasing bandwidth of the tuned circuit filter is reduced. Losses are decreased and energy stored is better. Oscillator phase noise Q factor is increased and the phase noise is decreased. General spurious signals with a higher Q factor value, the circuit will be able to remove the spurious signals. Ringing with Q factor increases, the losses decreases with otherwise means that the ring will be more. Thank you. We can see the bandwidth signal. The bandwidth of a signal is defined as the difference between the upper and lower frequencies of a signal generated as seen. And these are the Q factor definition. Q factor or Q factor is a dimensionless parameter that describes how underdamped oscillator or resonator is. This they defined as the ratio of the peak energies. And oscillating is the high Q, which while a pendulum immersed in oil as low one. Resonator with a high quality factor have low damping so that they ring or vibrate longer. And next, it is the numerical representation of the Q factor. It's the ratio of the energy stored in the oscillating damping. And it is the commonly available bandwidth. It is a diagram of the commonly available bandwidth of the speed, how to measure bandwidth signal, Q factor definition, Q factor representation of Q factor interpretation, Q factor effects. With the Q factor increases, bandwidth of the tuned circuit is reduced, lower or decreased, and energy stored is better.